Hello, my name is Ethan, and today I'm going to introduce you to the concept of chirality and discuss why it's important. Pesticides are widely used to protect the crops we eat from insects. However, as effective as they are, they don't just kill the bad insects that eat the crops, they kill all of the insects. This is bad, as some insects are important. These especially play a vital role in the natural world. They pollinate plants in their mission to create honey, allowing the plants to reproduce. Pesticides aren't just bad for insects either. When it rains, the chemicals run off the fields into our rivers, which is bad for aquatic life. The pesticide chemicals also last on the surface of your food, which is why you should always wash it before you eat it. Some of the chemists at Cardiff University and others have been working on chemicals which are able to only target the insects which destroy the crops. One of these is aphids. So how does this work? Insects use their antennae to feel and smell and almost see what is around them. Therefore, by targeting their antennae, you can get them to do what you want. Antennae interact with very specific molecules, often known as pheromones. Because the antennae are outside in the real world, there are lots and lots of other molecules around, so the antennae have to be really specific, often meaning one molecule does something completely different to a similar one. Of the molecules you can see now, the one on the left is the natural form, and the one on the right is the new one, made by scientists. The natural one acts as a repellent, and the new one acts as an attractant. As you can see, very similar molecules do very different things. By using the attractant, you can attract the aphids to a trap so that they don't destroy your crops. Both of these molecules are chiral. It's likely that this means nothing to you, but it's actually rather simple. Look at your hands. They're in fact chiral too. Chirality means that a molecule is non-superimposable on its counterpart. If you were able to disconnect your hands, you would never be able to orientate them to look the same. They would always look different. This is what chirality is. In a molecule, this is achieved by having 4 different groups around a central atom. In this case, I have starred it for you. You may only see 3 lines coming off, but this is because chemists are lazy and never draw hydrogens, even though they are there. So why is chirality important? Well, underneath you'll see the chiral pair, the other hand to the starting molecules. If you were to try and use these, then nothing happens. The aphids ignore the chemical and keep eating the crops. That is how specific the antennae are. These molecules may look quite complicated to you, so I'm going to briefly describe how these pictures relate to the 3D molecule. Each point where the lines change direction indicates a carbon atom. Carbon can make 4 bonds, and so arranges itself at the centre of a tetrahedron, shown by methane, the simplest organic molecule. Because carbon places itself in the centre of a tetrahedron, when it forms a ring, the ring cannot lie flat. That is why these molecules have a zigzag pattern at their centre. They are the rings drawn side on. This is a very complicated molecule, so I wouldn't worry if you struggle to see it. But just remember that molecules are 3D. Chirality is everywhere around us. One example is the sugar glucose, which effectively powers our bodies. Now, I'm going to show you something that is relatively unknown about chiral molecules, the fact they bend polarized light. Here, we dissolve a huge amount of glucose in boiling water and inject it into our detector. The detector has a camera observing the light intensity through 2 polarizers. By twisting the polarizers, I change the angle, and you can see the light intensity changes. If I set the light intensity as low as I can go and add some glucose, the light intensity should change. as the chiral sugar should change the angle the light hits the second polarizer. As there is an increase in the light intensity, we can conclude that glucose is chiral. So, why is understanding chirality important? Well, as I said before, it allows biological organisms to be very specific with which molecules to interact with, and understanding this can help protect crops, produce life-saving drugs, and even nicer smelling perfumes. Chirality is everywhere, and understanding it is very useful for scientists. Thanks for watching. I hope you learned something interesting.